Good morning, students. Okay, in continuation of inorganic chemistry, we'll see some more important topics. Here we'll have two topics in inorganic chemistry, one topic in physical chemistry. We have only three chapters, continuation. In that way, one more topic in inorganic chemistry, solvents. Already in this word, we listen in solutions. What is the meaning of solvent? The liquid which has capability to soluble the other products, we call as solvent. Suppose, simple example. Here, water is there. Here, kerosene. Taking kerosene. Add here some amount of sodium chloride. Here also add some amount of sodium chloride. Kerosene not having the capability to soluble capacity or dissolving capacity of sodium chloride. So this kerosene it here not considered as a solvent. Here water has capability to solve, but has capability to dissolving capacity or soluble capacity of sodium chloride. Then we call this one here water is called as solvent. And we have one more principle in solvent chemistry. I will give one statement based on that we will see. One statement is that light is also in light. This is the one important principle related to the solvents. Light is also in light. That means, polar solvents, polar compounds are soluble in polar solvents. Non-polar compounds are soluble in non-polar solvents. What is the meaning of polar solvent? What is the meaning of non-polar solvents? We'll see. First classification based on polarity. Based on dipole moment value. Which has dipole moment value? That is polar molecule. Based on polarity. Based on polarity, solvents are classified into two types. One is polar solvents. Second one, non-polar solvents. Polar solvents and non-polar solvents. Which can easily dissociate into two oppositely charged poles called as polar solvents. What are polar solvents? The solvent which can easily dissociate into two oppositely charged poles we call as polar solvent. If electronegativity difference is present in between the atoms, we observe the polar nature. For example, you take, what are the examples for this polar solvents? Water is the polar solvent, ammonia, polar solvent, acetic acid is also polar solvent. Polar means water is there, water easily dissociates into H plus and OH minus, oppositely charged two poles. This is positive pole, this is negative pole. Such type of solvents we call as polar solvents. Here in polar solvent, polar molecules only soluble in polar solvents. Polar molecules means sodium chloride easily soluble in the water. Sodium chloride easily soluble in the water. Why? Sodium chloride ionic compound. It is also ionizing compound or ionic compound. It also easily dissociates into poles. Na plus and Cl minus. Then, it easily dissolved in water. Its It's a polar solvent, it also polar molecule. So, okay, attraction forces between these two molecules increases. Attraction forces between two molecules increases means, okay, the compound easily soluble in the solvent. The compound easily soluble in the solvent. Okay, this is about the just polar solvents. And here, non-polar solvent, which cannot easily, okay, dissociate. Such type of solvent we call as non-polar solvent. The solvent which cannot dissociate into two poles, called as non-polar solvents. Example for non-polar solvents. Example for non-polar solvents: benzene, okay, toluene, ether, esters. So many are there. Hexane, heptane, okay, hexane, heptane, cyclohexane. All these are the best examples of the non-polar solvents. Over here, most of the organic solvents are non-polar solvents. Most of the organic solvents are, okay, non-polar solvents. Okay, here one simple one is the ethyl alcohol is there. Actually, ethyl alcohol organic molecule. It is non-polar. It is non-polar. It is soluble in benzene. It also soluble in water. What is the principle here? Polar soluble, polar, non-polar soluble, non-polar. But ethyl alcohol non-polar, but soluble in water. Soluble in water. What is the reason? This is due to hydrogen bonding. Due to hydrogen bonding, ethyl alcohol forms, okay, intermolecular hydrogen bonding with water, like this. Intermolecular hydrogen bonding with water. Acetic acid also, okay, form the hydrogen bonding with water. Alcohols, okay, alcohols, acids. Sometimes low molecular weight ethers also soluble in water due to only intermolecular hydrogen bonding. Lower aldehydes, lower ketones, lower esters, all lower molecules, most of the lower organic molecules, okay, soluble in water due to only one reason, that is intermolecular hydrogen bonding. Intermolecular hydrogen bonding. What is the intermolecular hydrogen bonding? The hydrogen bonding between two different molecules. See, this is the water molecule, this is the alcohol molecule. We call it as intermolecular hydrogen bonding. Okay, here the molecule, the hydrogen bonding within the molecule, we call it as intramolecular hydrogen bonding. What is the meaning of hydrogen bonding? Okay, the weak attraction forces between, okay, the weak attraction forces between highly electronegative atom and hydrogen, which should be attached to oxygen atom or highly electronegative atom. We call as, that one we call as hydrogen bonding. Hydrogen bonding may be of two types. One is intramolecular hydrogen bonding and another one is the intermolecular hydrogen bonding. Okay, here we don't want to discuss about the hydrogen bonding here. Just we discuss about the polar solvents and non-polar solvents. Polar solvents and non-polar solvents. Topic finished. This is the one type of solvents, one classification. Then in continuation, we'll see one more classification. Okay, here we'll see one more classification. What is that? Based on releasing of HPS ion. Based on the releasing of H+ion, solvents classified into two types. One is protic solvents. Second one, okay, non-protic or aprotic solvents. Non-protic or aprotic solvents. What are the protic solvents? What are the protic solvents? Which releases the solvent which releases the H+ion. Okay, here the solvent which releases the H+ion we called as protic solvents. The solvent which not release the H+ion we called aprotic solvents. Example for aprotic solvents: sulfur dioxide, aprotic solvents. Okay, benzene, ether, cyclohexane, hexane, heptane, toluene. All these are the best examples for the aprotic solvents. Which releases the H+ion we called as protic solvents. Example for this: water, ammonia, acetic acid. All these are the best examples for protic solvents. And here polar protic solvents, polar aprotic solvents. Some of the molecules are there. Okay, some of the solvents are there. Those are polar, but not provide. Okay, but not provide H+ion. Okay, here polar protic solvents. Non-polar protic solvents. Non-polar protic, polar protic. Polar means water is a polar protic. Non-polar, okay, protic. Non-polar protic. Different of the benzene. All those are the best example for this type of. And here protic polar are there. Protic polar, aprotic non-polar, protic polar. Okay, aprotic polar. Protic polar means H2O, HCl. All these are the best example for protic polar. Aprotic polar, DMSO, dimethyl sulfoxide. Okay, dimethyl sulfoxide, hydrogen sulfide. All these are the episodes, not hydrogen sulfide, only dimethyl sulfoxide, sulfur dioxide. All these are the best example for the aprotic polar. This is about the simple classification based on the H+ion and based on the polarity. Okay, then in continuation we will see the one more type solvent, universal solvent. Universal solvent. What is the meaning of universal solvent? Okay, in chemistry, water is considered as a universal solvent. Why? Most of the compounds, 99.9% compounds soluble in water. That's why it is considered as a universal solvent. And water, it is a colorless, odorless, tasteless, non-toxic, non-poisonous compound. Non-poisonous compound. Okay, we can purify easily. Purifying easily. And the boiling point range also very less, 0 to 100 degrees centigrade. Melting point and boiling point range. Melting point 0 degrees centigrade, boiling point 100 degrees centigrade. Okay, these are laboratory conditions range. Laboratory conditions range. And transparent. And it has a dielectric value and dipole molecule. It has some dipole moment value 1.85 device. It has maximum dipole moment value. Along with the dielectric constant. Dielectric constant of water is 78.5. That's why it has high dielectric constant, more dipole moment value. Okay, we can purify easily water, colorless, odorless, tasteless, non-toxic, non-poisonous compound. The boiling point and melting point range is very less. Melting point range is 0 degree centigrade, boiling point range is 100 degree centigrade temperature. And most of the compounds are soluble in water. And it is a cheap solvent. That's why it is considered as a universal solvent. That's why it is simply considered as a universal solvent. And hydrofluoric acid is there, liquid hydrofluoric acid. Okay, it exhibit all these, the dipole moment value more than this one. Dielectric constant value 83.8. Dielectric constant value. Liquid hydrogen fluoride dielectric constant value is 83.8. But it is not cheap solvent. Okay, it is not non-toxic. Okay, it does not have this easy boiling point and melting point liquid range. Melting point and boiling point, easy melting point and boiling point range. It behaves in different way. Okay, it is not transparent. That's why it is not considered as a universal solvent. This is about the just universal solvent. And protic solvents, aprotic solvents, polar solvents, non-polar solvents. Okay, suppose polar solvents, aprotic polar is there, protic polar is there. Aprotic polar means DMS form. Protic polar means water. These are the best example for the solvents. And here every solvent has some characteristics. Those are first one, characteristics of solvents. Every solvent should maintain range of melting point and boiling point. First characteristic. Okay, heat of fusion, molar heat of fusion. molar heat of vaporization. Molar heat of vaporization, dipole moment value, and dielectric constant value. Melting point. Okay, a solvent which has a limited melting point and limited boiling point, and which has exact melting point and exact boiling point, those act as good solvents. Water. Okay, for example, water. Melting point exactly 0 degrees centigrade, boiling point exactly 100 degrees centigrade, transition temperature exactly 373 degrees centigrade. It has exact and limited range of melting point and boiling point. Suppose sulfuric acid is there, the boiling point of sulfuric acid is more than nearly 400 degrees centigrade temperature. So we can't use sulfuric acid as a good solvent, and we can't use the sulfuric acid as a solvent. Okay, hydrochloric acid is a gas. Okay, it does not maintain limited range of boiling point and melting point. So hydrochloric acid also we can't use as solvent. The solvents which has limited range of boiling point and melting point, those only used as a good solvents. Those only acts as a good solvent. Those only used as a solvents. Okay. Then molar heat of fusion, molar heat of vaporization. What is that fusion means? A solid converts into liquid. One, and taking vaporization, one more. Liquid converts into vapor. Okay, during these two conversions, here solid converts into liquid. For the conversion of solid into liquid, we require some amount of heat that we call heat of fusion. The temperature, the heat which required for the conversion of solid into liquid, we call as heat of fusion. Okay, for the conversion of one more solid into one more liquid, we call as molar heat of fusion. That means it should maintain the particular molar heat of fusion and molar heat of vaporization. What is the molar heat of vaporization? First we will see the heat of vaporization. The temperature, the heat which is required for the conversion of liquid into vapor, we call as heat of vaporization. Okay, 1 mole of liquid, the heat or temperature which is required for the conversion of 1 mole liquid into 1 mole vapor, we call molar heat of vaporization. That means the solvent which acts as good solvent should maintain perfect molar heat of fusion and molar heat of vaporization. Then should maintain the dipole moment value and dielectric constant value. Which have not dipole moment value, that is non-polar. That means it has solubility toward the polar molecules. Dielectric constant value, which has less than 15 dielectric constant, those molecules are non-polar and not having the capability to Okay, soluble of polar molecules. The molecules which have the more dipole moment values and more dielectric constant values acts as a good polar solvents. Good polar solvents. This is about the characteristics of solvents. Next, in continuation, we will see the properties of solvents. Okay, what is the solvating capability? How solvent can soluble the materials? What is the reason behind it? We will see in continuation. After that, two important solvents are there. One is ammonia and another one is liquid hydrogen fluoride, liquid sulfur dioxide are there. We will see in continuation those solvents. Okay, thank you.